Okay, we're going to try a few of these videos on solutions for these movement problems. So the way I go about approaching these is whenever you've got a word problem, I always find it best to kind of come to the end, because at the end is where the question is. So find the rate of the rowing team in still water. That's what we're looking for. What that allows us to do is to come here, and the unknown, what we're looking for is always going to be, we could use our x, our unknown is x. What is x? It is the rate of the rowing team. In still water. Okay, so what we're going to look at these type of problems, a rowing team is going 100 miles, going with the current, and in the same amount of time it took to row 20 miles going against the current. So there's these a series of problems you'll face where on the water, or this could also be a plane in the air, they're flying against the wind or with the wind, with the stream, against the stream or the current. Okay, so we've got some river. Just gonna go ahead here, and we'll say it's flowing one direction. Let's call this downstream. This is the current. And when this rowing team was going with the current, they went a distance of 100 kilometers. So what we've got here is this is a distance. Okay. The same amount of time, so this is important. So time is constant, it's the same amount for both. It took it to row 20 miles going against the current. So from down here, in the same time is the same. They were only able to go 20 miles, not kilometers. Sorry about that. We'll just cross this out, not kilometers, miles. And then they give this information that the rate of the current was 6 miles per hour. So this current is 6 miles per hour. Okay. And these type of questions, distance, rate, and time, that's what ties them all together. We get that the distance equals the rate or the speed times time. Now, when we have settings where the time is equal, but we don't know what it is, one way to go about this is to solve this equation here, d equals rt. Solve it for t. So we'll divide both sides by r, and we get the new equation, or not really a new equation, but reorganized equation, that the time is equal to distance divided by rate. Okay, so notice x is the rate of the rowing team in still water. We have the rate of the current. So what is going to be the rate of the rowing team in the current? Start setting this up. So the rate of team with the current is going to be x plus 6, because that's helping them. The rate of the team against the current, it's this one here, is going to be their speed minus the current, minus 6. So we've got our two rates, we've got our two distances, right? So with the team, this is rate, kind of set up a little table here. their distance 100 when they went with the current, but only 20 when they went against. And what we're going to do is now set them up in a relationship like here. So what we have is the times are the same, so T equals T. And what is T? T is equal to the distance divided by the rate. Distance divided by the rate. And this first distance, we're going to use the 100 divided by its rate. So let me come up a little bit higher. Let's see. This is the next problem I'm going to want to work, and just give myself some room here. Okay, we'll come back to it. So what we're going to have is 100 divided by x plus 6 is equal to 20 divided by x minus 6. This is the key part. Once we have it set up, we've got this proportion. We can cross multiply. So that gives us, come over here where we have space, 100 times x minus 6 equals 20 times x plus 6. Distribute through. Oops. Minus 600. Distribute here, you get 20x. 6 times 20 is 120. And now get the x's to the same side. So we can subtract 20x from both sides. It gives us 80x here. Sorry, not plus, still minus 600 equals 120. Add 600 to both sides. And we get 80x equals 720. We then divide both sides by 80. And that's going to give us our, we'll just do it here, x. The zeros sort of cancel. 72 divided by 8 is 9. And x was what we were looking for. That's the rowing, the speed of the team in still water. And as we come back up here, that's the correct answer, 9 miles per hour. And I think what you probably found, let's see if you subtract, you might have found the rate of them going upstream or something. 9 minus 6 would be 3. Going downstream, it'll be 9 plus 6. They're going actually 15 miles per hour going downstream, but only 3 miles per hour going upstream is what their net result is. But so that's how we work that one. Oh, because I moved this stuff. So let's see if I can. So there we go. Now we're all lined up again, and that's good. Because what I'm going to do is make sure I have enough room down here to do this next one. Okay, so actually I should just, let's just do a insert page break, and we'll take at this look at this stab at the next one. And I'll do a couple more samples of these because they're similar but a little bit different. Okay, so now let's take a look. Back to our tools here. Again, we got a new problem, but what we want to do is go to the end. What are we looking for? Find the rate of the passenger train, just the passenger train. Okay, again, I haven't read anything else yet. But in my setup, I know what I'm looking for. X equals rate of passenger train. Notice I didn't even start reading the question yet. I just go right to the end. I have no idea what's going on in this question, but I know what I'm looking for. I need the rate of the passenger train. That's what gets me to focus. Now I switch gears a little bit, and I'm going to come back and I'm going to start reading through this. So now I've got my passenger train. Oh, great. That's what I'm looking for. It traveled 240 miles in the same amount of time. So again, remember that's going to be helpful in our setup since time is the same. It took a freight train. So we got something else. We're not looking, we don't really care about this freight train, but it will give us information that we need to use. The freight train traveled 160 miles. Okay. The rate of the freight train was 20 miles per hour slower than the rate of the passenger train. So here we've got some things, okay? So we've got the rate of the passenger train is X. The freight train is 20 miles per hour slower. So it is X minus 20. That's the rate of the freight train. So this is all helping us with our setup, okay? So I know the rate of the passenger train, then I take 20, I'll get the rate of the freight train. Again, very similar to the last one, what we're working with is distance equals rate times time, but in this case, since the time is the same and they didn't give us the time, we're going to want to solve this for t. So you'll see this will be the standard way we're going to use this formula. That time is equal to distance divided by rate. We've got their distances here, and we've got the rates here. So we'll set up our table sort of like what we did. Rate, we've got X, and distance is 240. So that's for the passenger train. The freight train is the rate is X minus 20, and the distance it went is 160. And now we're going to use this formula that their times are going to be the same. So we've got distance divided by rates should be the same. So the passenger train is 240 was its distance divided by its rate, which is X. The freight train is 160 divided by its rate, which is X minus 20, sorry, not 120. X minus 20. And then just like the last question, we are going to cross multiply. So we get 240 X minus 20 equals 160X. 240X minus 20 times 240, we'll get 2 zeros, and 24 times 2 is going to be 48. That's equal to 160X. Let's get the X's on the same side. So I'm going to go ahead and subtract 240X from both sides. That leaves us with negative 4,800 equals negative, think of it the other way around, 0, 6 from 14 is 8, and then so that's 80. X. We're going to divide both sides by negative 80. Zeros cancel. 480 divided by 8 is going to be 60. 48. And it will be positive. So 48 divided by 6 is 8. Sorry, 6. 4,800 divided by 8, 80 gives us 60. I guess I can use the eraser, but and when we go back up here, rate of the passenger train, it gave us the correct answer is 60. We had 6, so it might have been a division problem on this one, but you're close to it. So that's the first two. I'm going to send off this one, and then I will do another couple, but I will send the file as well with the work being shown, so maybe that'll be helpful too. So let me save this. Let me just stop recording just to make sure that everything is working just fine.